So first of all, I would like to thank the Sewa International for giving me this opportunity to represent CSIR IHBT on behalf of Dr. Akshay Kumar. So unfortunately, he was not able to come today. So CSIR IHBT has been working on the waste management on different aspects of mainly focusing on the organic waste since 2017, and we are working on different aspects to provide the sustainability for to maintain the agro ecosystem of the Indian Himalayan region. So moving forward, so if we look at the global organic waste market, it has been increasing rapidly with the growing population with the annual growing rate of 4.6%. And if we look at the disposal, its management approaches, we can see about 30% of the organic waste or the total waste ultimately accounts for the open dumping. Then around approximately 13% of the total waste is recycled and only 5.5% of the waste is composted. So if we move forward to the Indian Himalayan region, among the total waste generated, we have conducted a literature review uh, in 2020, and with the collecting the data from the CPCP, we found that among the total waste generated, about 55% of the total waste is the biodegradable waste, so which is an excellent resource for the recovery of the nutrients that can ultimately sustain the agroecosystems. So currently we are focusing on three different aspects. One is the human fecal waste, food waste, and also the improving the biogas plants for the process of the product development for the livelihood generations. So firstly, moving to the human fecal waste, we are mainly focusing on the traditional Himalayan dry toilets. So human excrement has been used by the ancestors since since ages for the use as a fertilizer, as a soil amendment. But due to the modernization, the introduction of the flush toilets, the use of the human excrement as a fertilizer has been declining. And for now, recently again, due to improve the nutrient management, the redirection of the human excrement into the agriculture has again gained attention, and the people are starting to move forward to use the human excrement in different ways through different technologies. One of them is the use of dry toilets or the bio toilets. There are different processes. One of them is the traditional dry toilets, which are prevalent in the Himalayan regions of cold deserts, that is Lahore and Spiti, as well as in Ladakh region. We are mostly focusing on these regions currently. So you can see in this figure, the basic structure of the dry toilets. It's a two-storied structure that is attached to the living rooms. So it consists of the two stories. The upper story is the defecation room where the individual defecates, and after defecation, to cover the feces, they make use of the readily available materials like the animal dung or any dry waste or the wood ash. And the lower story, that is the composting chamber, where the pile builds up and the pile stays there for around 6 to 8 months. So after 6 to 8 months, these piles, compost piles, they are emptied and then transferred to the fields, where they again remain covered under the snow for around 5 to 6 months. Now the major challenges that is faced by this process is the extremely cold climate, because of which the composting process, the natural composting process, is hindered, and, and there is a production of the foul odor, and the compost produce is of a low quality. So to this here is an overview of the process. You can see the piles, NSC piles, the compost piles are dumped into the open fields in a series of piles. Then they remain covered under the snow. Once then, after the snow melts, the compost piles are then mixed with the soil before sowing, and used for the cultivation of the different cash crops. Now, although this structure and the process was documented already by S. Shantaram Oinam and his team way back in 2005, there was no scientific validation of the process or the compost quality assessment was done. So, we took the initiative to perform the assessment as well as the quality and the safety of the compost that is produced using this traditional dry toilets. And we were lucky to be funded by the NMHS. So I would like to thank the NMHS for trusting us and believing in us, and they funding us to carry out the work on improving the traditional dry toilets through microbial interventions. So with this project, we performed the quality assessment where we checked the different fertility parameters and compared it with the FCO standard that was provided by the solid waste management rules, 2016 rules of Government of India. And we found that using this parameter, we calculated the fertility index, which was around 4.46 with potentially high fertilizing efficiency. So apart from the quality, we also checked the safety of the compost for the plant through phytotoxicity assays. We checked the germination index of the compost on using the pea plants. So we found that the germination index was more than 85%, that indicated the low phytotoxic effect of the compost. So it was safe for plant use. So apart from this, we also checked its efficiency, the compost efficiency on plant growth and the yield of the product. So we found a very good results of in the pots that were supplemented with the night soil compost. Then we also ensured that the compost that was produced through these toilets is safer for the humans or not, because ultimately the compost is used for the production of the food crops and which are consumed by the human. So we ensured that we evaluated the safety through microbiological analysis, and you based on the most probable numbers of the fecal coliforms, we classified the night soil compost and based on as per the US EPA standards, and it was found to be a class A compost with safe and acceptable levels of pathogens. Then we also checked the microbiome analysis, where we checked the different microflora of the compost that is present in the compost, and we found 14 different phyla with proteobacteria as the dominant phyla, and proteobacteria plays a very important role in composting, aerobic composting. So using this data, we also checked the to validate the our microbial analysis. We checked the pathogenicity as well, reconfirmation, and found that it is safer, non-toxic, and is of good quality and can be safely used for the food crops. So this study was recently published in Waste Management Journal and also covered by Nature India and the India Express. Now, what is exactly happening in the cold regions, how the process is affected? Now, although the composting process is already being conducted in this region, the process is very long. The duration of the process is quite long. It's 6 to 8 months it takes. So that is because of the cold climatic conditions. Now, why it is being delayed? Here is a brief general introduction. You can see this figure. It's a general process of the composting which occurs in the mesophilic condition. So it consists of three phases: the mesophilic phase with a temperature range of 25 to 40 degrees centigrade, the thermophilic phase with the temperature range of 40 to 65 degrees centigrade, and the third is the cooling or a maturational phase with temperature less than 40 degrees centigrade. So what happens in the mesophilic phase is the mesophilic microorganisms present in the pile, they easily feed on the readily available materials, that is sugars, amino acids, proteins, whatever it is available, and they starts growing. So as the metabolic activity increases, the temperature within the pile, they starts to rise. As a result, it exceeds the 40 degrees centigrade, and the process then move towards the thermophilic phase. So allowing the thermophilic microorganisms to carry out the further degradation process. And as the organic matter starts to exhaust, the temperature again starts to decline, and the cooling or a maturational phase starts. Now, what happens in the cold or extremely cold climatic conditions is that the mesophilic microorganisms, since the temperature is very low, they are not able to grow. So, as a result, the temperature is not raised. So, here plays the role of psychotrophic bacteria or any other microorganisms, which starts to feed on the organic matter. They starts to as they grow, the temperature rises, allowing the or making the favorable conditions for the mesophilic microorganisms to grow. So and the continuation of the rest of the process. So, in without psychotrophic bacteria, the mesophilic phase is extended. As a result, the thermophilic phase is shortened. So, which is a drawback in composting, because during the thermophilic phase, all the pathogenic microorganisms or the weed seeds or the insects larvae, they are all destroyed, and the compost quality is improved. So, here the psychotrophic bacteria, they aid them or they support or they help in the onset of the composting process. So with this hypothesis and aim, we collected different samples of the compost along with the night soil compost that was recovered from the dry toilets. We recovered the bacteria, then screened them for the different hydrolytic enzymes so as that they can degrade the organic matter. As an add-on, we also check their plant growth promoting traits, as ultimately the product will be going to the fields to support the plants. So around approximately 300 cold adapted bacteria we have so far recovered and are used for the different aspects on this. So after the initial screening, we quantitatively assayed them for selecting the best hydrolytic microorganisms, and the organisms that were able to produce more than 2 and the highest hydrolytic activities were selected for the formulation. So, since they were recovered from the fecal organic matter, they were the safety. It was necessary to ensure the safety of the microorganisms. So, we also said their safety by checking if they were hemolytic or not, they were able to produce the biofilm or not, and then so after that we also checked it on the cytotoxicity, cytotoxicity against the human carotenoid site cell lines to ensure their safer human handling. Apart from the human safety, we also checked their phytotoxicity for the plant safety, and those that were showing the phytotoxic effect were removed from the formulation. So then, after selection of the bacteria, we since the dry toilets concept of the dry toilet, they are completely waterless, and there is a water scarcity issues in this region. We could not make use of the liquid formulation and had to choose some carrier material. So here we use the bamboo biochar as a carrier material. Along with this, we also use the coco peat as a bulking agent and prepared a final product, that is the compost booster, which we named it. These are the two products. One is the liquid formulation and uh, the compost booster, the dry formulation. Sorry. These are the results of the trial results of using these products, and we found the quality of the compost that is produced was very good quality compost. Again, the fertilizing efficiency. No, here is a structure of the modified dry toilet. Now, although the product was working efficiently in this region, so due to the mixing of the urine, because the traditional dry toilets, they don't have any provisions for the separation of the urine, so urine gets mixed with the pile, and it's affecting the efficiency of the product. So now currently we are focusing on the improving the structure of the dry toilets. So here is an just a prototype of the structure where we are separating the urine, and the urine that is separated is treated separately to produce the urine based biofertilizer. So we are having, with this prototype we will get two products. One is the nutrient rich manure as well as the urine based biofertilizers. So this where the kitchen booster was also tested on the kitchen waste as well. These were the results. Apart from this, we also recovered the anaerobic microorganisms for the improvement of the biogas plants. And currently, we have installed two biodigester. One is in the Bajnath, Himachal Pradesh, and one is in the Sikkim. So, which is efficiently treating 250 kg of the organic waste using our formulations. These are the plant growth promoting bacteria case study. So we have some of the partners that are currently involved with us, with who are distributing the different products in different ways. So we have two industrial partners, some of the societies and village panchayat of the Lahore Valley, then government partners, and the MSME Spurti through scheme. We are also producing this. So with MSME scheme, we have 400 beneficiaries who are currently producing the vermicompost as well as the enriched compost and are selling it in the market. So currently, CSIR HPT is the technical agency providing the technical advices for this, and we have also given them the central facility, providing different instruments, equipments for the quality assessment of the compost which they are producing. So these were the instruments that were provided to the products that were produced through the MSME clusters. These are the success stories that was covered by the India Science. Again, that's it. Thank you.